We are going to learn the share method using an example. Let's take the function y equals x minus 3 quantity squared times the quantity x minus 1. We are interested in the region between the graph and the x-axis, the shaded area. Now imagine rotating this region around the y-axis. As it spins, it creates a large three-dimensional solid. At first, finding the volume of that entire shape seems impossible. So instead of looking at the whole thing, let's zoom in by drawing a tiny vertical strip inside the region. Thickness is delta x. Now rotate this tiny vertical strip around the y-axis. As it spins, it creates a thin cylindrical shell like a hollow can. Now imagine many of these shells. The strips stretch from x equals 1 all the way to x equals 3. And the height of each strip changes according to the graph because the height is determined by the function value. If we add all these shells together, they create the entire three-dimensional solid. That's exactly what integration does. Integration adds infinitely many tiny pieces together. Now let's identify the dimensions of one shell. First, the height. The height is simply the function itself, f of x. Since the function gives the y value at each x position, that y value becomes the height of our shell. Now let's talk about the radius. Actually, the strip is not located at one exact x value because it has thickness. It stretches from x to x plus delta x. Half of the strip's width is, technically, the shell radius should be, but as delta x approaches 0, the strip becomes thinner and thinner, then x plus delta x over 2 gets closer and closer to x. So in the limit, the radius becomes simply x. Now let's find the volume of one shell. To make the volume easier to visualize, let's roughly think of the shell as a very thin rectangular prism. Circumference, the height is f of x. So 2 pi r times f of x times delta x gives an approximate volume of one shell. We take the sum and examine what happens as delta x approaches 0. That limiting process is exactly what an integral represents. So this volume equation means take infinitely many shells, add them together, and find the exact volume created by rotating the region. That integral literally represents the volume of the rotated solid. We started with one tiny strip, turned it into a shell, built infinitely many shells, took a limit, and discovered where the formula actually comes from. That's calculus.